My name is Christian Team, and I am the project manager for the Sustainability and Resiliency Department in the City of Salem. I'm going to walk through different design options that can be built to protect the Palmer Cove and Pioneer Terrace area from coastal flooding. As sea level rises, the frequency and intensity of coastal flooding increases over time dramatically. We are basing our planning on high sea level rise projections, so if sea level rises at an intermediate rate, the risks may happen 20 to 30 years later than we are showing you. This map provides a neighborhood-level view of the future impacts of flooding. The red and maroon areas mark community assets like childcare, small businesses, community centers, and recreation areas in the Point neighborhood. Areas predicted to be impacted by coastal flooding in the 2030 time period are shown in blue. The darkest blue areas are predicted to flood in a common storm with a 100% annual chance of occurring. The medium blue areas would flood in a likely storm or one with a 10% chance of occurring. And the light blue areas would flood in a rare storm, one with a 1% chance of occurring in any given year. When you get to 2050, these projections show rare floods from 2030 becoming likely and likely floods from 2030 becoming common. In 2070, the pattern continues where a common storm will cause flooding in much of the Palmer Cove area. We're speaking today of potential projects on city-owned land, but any future projects will need to be coordinated with similar efforts on privately owned sites, such as Shetland Park and the Palmer Cove Yacht Club north of the park. If flood protection measures are not incorporated on these adjacent sites, then city efforts will not be effective in mitigating the flooding. Currently, along the city-owned stretch of coastline, there is a small seawall as well as a revetment that was constructed in the 1940s. Now, we would like to talk about the design options to protect against future flooding in the Palmer Cove Park area. Our goal with engaging with the community is to understand your preferences and priorities based on how you currently use and what you value about that area. We do not expect anything to be built for some time, 5 years at the earliest. The target outcome at the end of this phase is the design that is generally supported by the community. The first alternative we have is quite simple. It is to raise the seawall. For all the alternatives, we are proposing to build these incrementally. The first installation will be built to protect against shorter-term sea level rise, and then they can be added to if needed in the future. The alternative allows for a majority of the current roadway to be maintained. And you can see from these pictures that as the wall height increases, we could build walkways on the landward side to allow people to see over it. We've created some mock-ups of what each alternative might look like at the site and the impact they would have on the water views. This slide is showing present-day pictures of Palmer Cove Park and Pioneer Terrace south of the park. This rendering shows the impact the seawall would have on the view of the water if it is built to protect against 2050 levels of flooding. This rendering shows the impact the seawall would have on the view of the water if it is built to protect against 2070 levels of flooding. And this slide shows some real-world examples of seawalls to give you a sense of what they look like. Alternative 2 is very similar to Alternative 1. It would involve building a seawall, but the revetment would be demolished. The demolished area would be made into a vegetated sill and terraces, where coastal plants could be grown that would help protect against flooding and reduce wave strength. Materials from the demolished revetment would be reused when possible during the project. The vegetated sill and planted terraces portion of this project would be challenging to build because it would require building in a coastal resource area, which is valuable to the community and the environment. It is also close to navigational waters. For these important reasons, this would be a challenging project to permit. This slide shows some real-world examples of planted terraces to give you a sense of what they look like. Alternative 3 demolishes the existing revetment, reconstructing it to modern design standards. It would be made of the same type of stone used currently in the revetment. This is different from the other alternatives, as it extends a little bit further into the water, especially at Pioneer Terrace. Like the vegetated sill and planted terrace in Alternative 2, this would require building in a coastal resource area near the navigational waters. So building there is not ideal. It would also be a challenging project to permit. This slide is showing present-day pictures of both Palmer Cove Park and Pioneer Terrace south of the park. This rendering shows the impact the revetment would have on the view of the water if it is built to protect against 2050 levels of flooding. This rendering shows the impact the revetment would have on the view of the water if it is built to protect against 2070 levels of flooding. This slide shows some real-world examples of revetments to give you a sense of what they look like. Alternative 4 would be to build an earthen berm that also keeps water out of the park, specifically for the part along Palmer Cove. This would only be built at Palmer Cove Park, and another alternative would have to be chosen for the part along Pioneer Terrace because there is not enough room between the buildings in that area and the coastline. So, for example, along Pioneer Terrace there could be a seawall, and that would connect with the berm at Palmer Cove Park. So here we have a present-day image of Palmer Cove Park. And again, for Pioneer Terrace, another alternative would have to be implemented. This rendering shows the impact the berm would have on the view of the water if it is built to protect against 2050 levels of flooding. This rendering shows the impact the berm would have on the view of the water if it is built to protect against 2070 levels of flooding. This slide shows some real-world examples of berms to give you a sense of what they look like. So these are the solutions, but there are other things we need to consider. Effectiveness, permitting, maintenance, and also cost. Here we have an image that represents the advantages and disadvantages of each alternative. The lower scores would be represented by an empty circle, and the better scores would have a filled blue circle. It is important to point out that all of the alternatives would adequately protect the areas against projected 2070 levels of flooding. These scores are meant to provide a visual aid on some of the trade-offs of each alternative, which are important to consider, but should not be seen as an endorsement of any one of them.